Alright, today we're going to do lesson 3.5, and we are learning how to graph linear equations that are in slope-intercept form. Okay, as a quick review, I do want to talk about, because it says today our essential question is how can you describe the graph of the equation y equals mx plus b? So as a review, yesterday we learned about the equation of a line in standard form. Who can raise their hand and remind us all what is an equation in standard form? What does that look like? If you need to flip back in your notes, that's totally fine. But I want someone to tell me what standard form looks like. I want everybody looking back. If you don't know it, I want everybody looking back. All right, Harley, what does standard form look like? No, give me the formula. I just want the formula. There we go. AX plus BY equals C. And then, of course, today we're looking at slope-intercept, which is y equals mx plus b. Now, here's why I want you to see the difference. In standard form, the x and the y terms are on the same side of the equal sign. All right? In the slope-intercept form, what variable is by itself? Y. Okay, why is it important for you to recognize the difference? Because I'm teaching you different ways to graph different types of lines. If you're looking at a quiz next week and you see graph the linear equation, I want you to be able to look and say, oh, that's standard form, so I can find the intercepts and I can graph that, right? Isn't that what we learned yesterday? Standard form, quickest way to graph it, find the intercepts and graph those two intercepts, okay? Or I want you to be able to look and say, oh, that's slope-intercept form, this is what I'm going to do, because we're going to learn today exactly what to do. All right, so that's why I want you to be able to recognize AX plus BY equals C is standard form, y equals mx plus b is slope-intercept. Now, we got to talk about slope. All right, slope. Definition of slope is the rate of change between 2 points on a line. So there's a couple ways that we can represent this. M is equal to rise over run. Okay, and you can see in your notes, I was very, very specific. Rise is your up or down motion. Run is your left or right motion. A lot of people think that slope is an ordered pair. They think it's a point. But slope is a direction. It's a movement. It's two movements to be exact. We are going to either go up or down, then we're going to move right or left. All right? So that is another way that we can represent slope. Then, of course, for those of you that are highlighters, circlers, okay, there is your slope formula. So that is the formula that you want to memorize, you want to love, you want to learn. Okay, now it looks maybe a little different than what you've learned in the past. In the past, you've been taught m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's great. If you know that formula, if you have memorized that formula, please feel free to use it. I prefer not to put the sub 1s and the sub 2s because I feel like it's easier to memorize m equals y minus y over x minus x. Here's the bottom line. The sub 1s and the sub 2s are there for this reason. They want to make sure that your first y coordinate and your first x coordinate come from the same ordered pair. They want to make sure your second y coordinate and your second x coordinate come from the same ordered pair. So if you can remember that without needing the sub 2s and the sub 1s, then you could just learn the formula like I have it. But again, if you like the other formula with the sub 1s and the sub 2s, I'm fine if you use it. Now, there are 4 types of slopes. We have a positive, a negative, a zero, and an undefined. But we've got to be able to look at a graph and decide quickly, is that positive, is that negative, is that zero, or is that undefined? So hopefully you've been taught in the past, when I'm looking at a graph, I look at it from left to right. So if my slope is positive and I'm looking at it from left to right, what should my line be doing if my slope is positive?
It should be going up.
Okay, it should be going up. Does everyone agree with that?
Yes.
All right, so I want everybody to sketch a line that shows as I look from left to right, that line is going up. Now, what happens if my slope is negative? If I'm looking at a line from left to right and the slope is negative, what is the line going to be doing? Going down. So sketch yourself the picture of a negative slope. That's a line that as I look from left to right is actually going down. Now, 0 and undefined tends to cause problems, so let me give you a couple of helpful tips. Okay? First of all, yesterday we had vertical lines and we had horizontal lines. So a horizontal line has a slope of 0. And I want to prove it to you. If slope is rise over run, I want you to look at this horizontal line. Is there, if I'm trying to go from point to point, is there a rise on this line?
No.
No, there is not. Which means my numerator is going to be what value? 0. If there is no rise, my value is 0. So do this. I want you to take your calculator. I want you to do 0 divided by, and you can punch any number that you want into the calculator after that. So 0 divided by whatever number gives you what? 0. Okay? So when my numerator is 0, my answer, my slope, is going to be 0. Now, look at this. I saw this last year. I learned it, and I love it. Some of you are going to love it. Some of you aren't going to care about it, but that's okay. Look at it anyways. When I write the word 0, what is the first type of line that I have to draw to write the letter Z? A horizontal line. So, if you need a way to remember that horizontal lines have slope of zeros, remember when I write the word 0, I am writing a horizontal line. Okay? Now, the other type of line is a vertical line. So go ahead under undefined and write vertical. But again, I want to prove it to you. Does a vertical line have a rise? Yes. Okay, if I'm trying to move from point to point, I can rise. Does a vertical line have a run? Which means the denominator has to be what? 0. Now do this in your calculator. Pick any number you want. Divide it by 0. So punch a number in your calculator, then hit divided by 0. And somebody raise your hand and tell me what your calculator says. Landon. Error. Because guess what? You cannot divide by 0. So that is why the slope of a vertical line is undefined. Because your denominator, your run, is going to be 0, and you cannot have a denominator of 0. Okay? Any questions so far? Now that brings us to example 1. It says, describe the slope of the line, then find the slope. We've talked a lot about making sure you understand what the directions are asking. So, if I want you, Michael, to describe this slope, what kind of a slope is it? Negative. Okay? If I look at that slope from left to right, it is absolutely falling or going down. So, that is the first part of my answer. To describe the graph, I'm simply telling if it's positive, negative, 0, or undefined. Okay? Now they want me to find the slope. So, let's do a little hands-on experiment before we do this. I have to decide if I want to start at negative 5, 2, or if I want to start at negative 1, 0. There really is no right or wrong answer to that. So I'm going to start at negative 5, 2. Now from that point, I have options. I can either go right until I'm lined up with negative 1, 0, or I can go down. All right, so I'm just going to go right. I'm going to go right, and I'm going to stop when I'm lined up with that negative 1, 0. Now, how many spaces did I just move? 4, and I went to the right. So on a coordinate plane, if I'm moving right, is that a positive direction or negative direction? Positive. So that's a positive 4. Now, once I go to the right, I then have to go down. Now, how many spaces down did I move?
2.
And I went down. So what kind of 2 is that? Negative. All right. If I'm going down on a coordinate plane, that is a negative direction. Now, based on our definition, slope is equal to rise over run. So all I have to do is figure out which of those numbers is my rise and which of those is my run. All right, so which is my rise? Julia?
Your rise for A.
Yep, which is my rise and which is my run?
Your rise is
Negative 2 is my rise number, and what is my run number? 4. Now, it's a fraction, and what do I always have to do with fractions? Reduce. So my final answer is m equals negative 1/2. Now, we've talked a lot about making sure our answer makes sense. If we describe our graph as negative, is our answer a negative number? Good. If I say it's negative, but then my answer comes out to be positive, I should know I did something wrong and I got to go back and figure it out, okay? But this one's perfect. It's negative. As I look at it, it falls. I know it's negative, and my actual slope did come out to be a negative number. Now let's look at letter B. We're going to do letter B the exact same way that we just did letter A, even though right now it doesn't look like we can. All right, we have got to identify 2 exact points. Now when I say exact, I'm saying I would not use this point right here because your ordered pair would have to have a fraction in it. So we want to find 2 points that are really right on the corner of our little graph, like right here on the corner, because that's going to be an exact ordered pair. So does anybody see a very exact ordered pair? Jamie?
There's one on 0, -3.
Perfect. There's one at 0, -3, and there's one at, Harley?
5, 1.
5, 1. Perfect. So, we've got some choices. All right? Eric, which point would you like to start at?
0, -3.
Okay, 0, -3. And from there, would you like to go up or down? I'm sorry. Up or to the right are your options.
To the right.
Okay, so he wants to go to the right. If some of you want to be fun and go up and see if you get the same answer, do it. He wants to go right. Eric, how many spaces to the right did we just move?
5.
And we went to the right. Is that positive or negative?
Positive.
Positive. Okay, from there, Eric, we have to go up, and we just went up how many spaces?
4.
Positive or negative?
Positive.
We went up, which is positive. So let's describe this graph. Before we find it, let's describe it. Jace, what kind of graph are we going to have? Just by looking at the line, what kind of slope should we have?
Negative.
What's that line doing as it goes right to left?
It's positive.
It's positive. It's rising as we go from left to right, so it's positive. So that's our first answer. And then our slope is, Isaac, what was our rise value?
4.
And what was our run value?
5.
Okay. Will that reduce it all? Nope. So we're done. Now, we said we described it as positive, and our actual slope is positive. So we're in good shape. Are there any questions? All right, now let's look at example 2. This says find the slope of the line represented by the table of values. Again, we have options. These are ordered pairs. What could we do with all these ordered pairs? We could graph them, and then we could do what we just did. But probably nobody right now is really feeling the graphing. So that brings us to our slope formula. How many points do I need in order to use the slope formula? Y minus y over x minus x. How many ordered pairs do I need to use the formula? Class? 2. How many ordered pairs are on this table? 4. Does it matter which 2 I choose? No, it doesn't. So let's pick a pair. I'm going to pick 2, 10 and 4, 15. Again, if you want to be fun, go ahead and pick 2 different pairs and let's see if we get the same answer. Now my formula, which I always want to write down, especially here at the beginning because I want to make sure you got it memorized, write down m equals y minus y over x minus x. Now this is what we were talking about earlier. We don't care what order we do y minus y. We can do whatever we want. All right? So Reagan, what do you want to do as far as y minus y?
15 minus 10.
Okay, Reagan wants to do 15 minus 10. Now, because, Reagan, you chose 15 minus 10, what order are you going to have to do your x's?
4 minus 2.
There you go. Now, watch that. She did 15 minus 10. Because of that, she has to go back and do 4 minus 2. The 15 and the 4 come from the same ordered pair. The 10 and the 2 come from the same ordered pair. Is everybody good? All right. Now, let's do the math. M is equal, and I'm going to have to come over here. M is equal to what? What's 15 minus 10?
5.
And what is 4 minus 2?
2.
2. Will anything more, can anything more be done to that fraction? Yes? No? No. So that is my slope. Now, did anybody pick different ordered pairs and get the same exact answer? Awesome. And you can. It doesn't matter. As long as you pick 2 points, it doesn't matter. Now, look at letter B. We can do the same thing we just did. We've got a table of values. We can pick 2 values. We can solve using our formula. But does anything jump out at you when you're looking at that table? All right, Julia. Okay. My x's are the same, which technically means that this line reads x equals 5. Now, we learned yesterday when the equation is x equals 5, what kind of a line do we have? Does anybody remember? Think about think about your graph. From the center, you go to the right to 5, plot your point, and then you draw what kind of a line? A vertical line. So, what kind of slope do vertical lines have? Think about it. Is there a rise? Does the vertical line have a rise? Yes, but does it have a run? No. My denominator then is 0, which makes my slope undefined. All right. Now, I know there are some of you in here and you are just lost. Okay? And that is okay. Some of you are like, awesome, there's a shortcut, I'm great. Some of you are like, I'm lost, I'm going to cry. All right? Don't cry. Pick 2 points and let's work it. So 5, negative 12, and 5, negative 6. We're going to do the formula. So m equals y minus y over x minus x. And I'm going to choose negative 12 minus negative 6 over 5 minus 5. Now, what jumps out at you right here in the slope formula? Double negatives, which become positive. So m equals negative 9 over what? 0. All right. And if it doesn't already jump out at you, wait a second, I can't have a denominator of 0. Stick it in your calculator. What does your calculator say? Error, right? And when it says error, that lets me know that my slope is what? Undefined. So it is totally, I'm going to abbreviate, totally up to you which way you see it. All right. If you don't see that all your x's are 5, so the line's vertical and it's undefined, just use your formula. Okay. Let me throw this out there at you. What if all your y values had been the same? What kind of line would you have? What kind of line? Horizontal, and your slope would have been 0. Very good. Are there any questions? All right, let's go to example number 3. All right, we do need to fix that. So negative 12 plus 6 is actually what? Very good. But negative 6 divided by 0 is still what? Still undefined. Okay? Good catch on that. Now, the slope-intercept form of a line. Before we can go to example 3, we got to look at the slope-intercept form of a line. Okay? Now, y and x are they don't change. If it's in slope-intercept form, you're going to have a y, you're going to have an x. The changes are your slope and your y-intercept. Now, let's talk about the fact that n is representative of our slope, which we've been working on all hour so far. Okay, but let's talk about the fact that b is your y-intercept. That's a word you learned yesterday, a term you learned yesterday. So that value right there, whatever it is telling us where our line is going to intersect what? If it's the y-intercept, it's telling us where our line is going to intersect or intercept the what? All right, if you need to look back at yesterday's notes, look back at yesterday's notes. What is a y-intercept? We found x and y intercepts yesterday and we graphed them. So what is the y-intercept telling me?